When you're doing a question like number 1 and you're trying to figure out all the different possibilities, all the different outcomes, you need to use the fundamental counting principle, which means you take all the numbers and you multiply them together. So 3 times 3 times 2, which is 18. So there's 18 possible outfits. Next, we have 13 softball players, and we want to choose a pitcher and a catcher. So we have 2 different positions we need to choose, and it does matter who is who. So the order does matter, which means that this is a permutation. So we have 13 players. We are choosing 2. So you can make your calculator do that operation, 13, and then math over to probability, pick the P, type in 2, because we're choosing those 2 positions, and your calculator will tell you there are 156 ways. Next, we want to figure out how many different ways we can send 6 people to the media center. Since we really don't care the order that the people go to the media center, this is a combination. We have 23 students in the class. We're choosing 6 of them, so you need to type math over to probability, choose the C, type it in, and your answer will be 100,947. To count the number of ways a driver and navigator could be chosen, we have a driver and a navigator, so it matters who is who. You have to have somebody with a driver's license driving, and you have to have somebody who knows how to read maps to navigate. So they're 2 different groups, and that means, or 2 different roles, it means you're going to use a permutation. If you were not born in July, it means you were born in January, February, March, April, anything but July. There are 11 months out of the 12 months that are not July, so you type that in your calculator, 11 divided by 12, just like this, 11/12, and it'll give you 0.916. It says to express our answer as a percent, so we will move that decimal 2 places and round it up. So instead of 91.6%, we'll put 92%. Next, we have a bag with some crayons in it. We need to figure out how many bags or how many crayons are in the bag total. 8 and 2 is 10, and 5 is 15. So there's 15 crayons in the bag. We want to pick a yellow one. Well, there's 2 yellow ones. So 2 out of the 15 crayons are yellow. So type in 2 divided by 15. You get 0.13. And you move the decimal over 2 places, and it gives you 13%. Now we have a bag with ribbons in it. There are 3 black and 9 green. So I know there's a total of 12. First, Jackie's going to pick a ribbon, and then Amy's going to pick one from the ones that are left after Jackie takes one. So we're trying to figure out the probability that first Jackie selects a black one, so she's going first when all 12 ribbons are in the bag. At that point, there's 3 black ones. So 3 out of 12, 3 are black out of the 12 when Jackie chooses a ribbon. And so we multiply, then Amy's going to choose. Well, now there's only 11 ribbons in the bag, and Amy wants to select a green one. Well, you assume that Jackie got what she wanted. You assume she took a black one, which means that even though there's 11 ribbons left in the bag, there's still all 9 green ones, which is what Amy wants. So we put a 9 on top, and then we multiply. So 3 times 9 is 27. 12 times 11 is 132. And when you divide those, 27 divided by 132, you get 0.2. And if you move the decimal 2 places here, that's 20%. Don't skip the first part of this question. Why are drawing a jack or a 7 mutually exclusive? Exclusive means there's no overlap. Excluded means they're separate. So drawing a jack and drawing a 7 are completely different events. You're never going to have a 7 of jacks or anything like that. So now we want to find the probability that we draw either a jack or a 7. So for this, we're going to figure out how many jacks there are in the deck. 4 out of 52. The word or means that we add, and now we figure out the probability of drawing a 7. There are 4 7s out of the 52, so we have to add those up. Luckily for this problem, the denominators are the same. So the whole thing will be out of 52, and on top we just add those together. 4 plus 4 is 8. So altogether that's 8 out of 52, or if we reduce it, it reduces to 2/13. Or if you divide those, you get 0.15 or 15%. Alright, now Pam is rolling a number cube. First she wants to roll an odd number, and I know that D shouldn't be there. Well, how many odd numbers are on a number cube? 3 of them. 3 out of the 6 are odd. The 1, the 3, and the 5. Those are odd. Or, so now we have the word or, so we add a number greater than 4. Well, which numbers are greater than 4? 5 is greater than 4, and 6 is greater than 4. So 2 numbers. 2 out of the 6 are greater than 4. But we have to figure out if we have any overlap. Is this mutually exclusive? No, because 5 is both odd and greater than 4. So since there's one number that overlaps, we need to take that away. So we're going to take away 1/6. So on the bottom, 6 stays. 3 plus 2 is 5. And then we'll take away the 1. So that's 4/6, which reduces to 2/3 or 67%. For number 10, independent events are when the probabilities do not affect each other. So the probability stays the same, try after try. Dependent events are when the first outcome messes with the second. First outcome affects the second. So like the example with the girls drawing ribbons out of a bag. So once you take one out, then it changes the probability for the second event and the third event and so on. But something like flipping a coin, that's an independent event because every time you flip a coin, your probability is 50-50 heads or tails. For a problem like number 11, you need to enter that list of numbers into L1. So you go to Stat and Edit. Make sure that only L1 has numbers in it. And then to get all of these things, you press Stat Calc 1, which is one variable stat. We only have one list. So we go through and we write down the mean. The mean is X bar, and that will show up as 7.9. The median, you have to scroll down a little. It'll say MED on your screen, and that's 9. The mode, you have to just figure out what the mode is. See how there's 3 9s? That's the most frequently occurring number, so the mode is 9. And it's okay that the median and the mode are the same number. The range, you take the highest number and you subtract, the lowest number. High minus low. So the highest number is 11, the lowest number is 2. 11 minus 2 is 9. Again, this is just a coincidence that all these answers are 9. And last, the standard deviation. That's the little sigma that looks like that on your calculator. And that number is 2.8. You can have the calculator draw you a box and whisker plot, or you can just have it tell you the information and you can draw it yourself. So you do everything exactly the same as we did in number 11. You take all the numbers in that list, you put them in L1, you press Stat Calc 1, and you copy down all these things from your screen. The minimum, the lowest number is 1. It will say Q1 when you scroll down on your screen. It'll tell you what Q1 is in the big list of numbers, and Q1 is 2. The calculator will tell you the median is 4. Q3, it will say 8.5. And the maximum, the highest number, is 11. So those 5 numbers are the things you need to put on the box and whisker plot. The whisker is 1. The first side of the box is 2. The middle of the box is 4. The right side of the box is 8.5, so halfway between 8 and 9. So now we have the box where that's Q3, that's the median, that's Q1, and then the other whisker is the maximum up at 11. Are there outliers? If so, which ones? Well, none of those whiskers look that long, and the answer here is no. There are no outliers. None of those whiskers are 3 standard deviations away from the mean. Between what numbers is the middle 50%? Well, the whole point of a box and whisker plot is it divides your data up into quarters. So between here and here, that's 25% of your data. That's a 2. Between here and here, that's 25%. Between these two, it's 25%. And between the last 2, that's also 25%. So it divides it into quarters. So the middle 50% is the middle 2. That's where your box is. So between what 2 numbers? 2 and 8.5. 2 to 8.5. That's where most of your data lies. If you have a data set that's normally distributed, so the bell curve, this one, how many standard deviations away from the mean are outliers? Well, remember, the mean is in the middle, x bar, and outliers are more than 1, 2, 3 standard deviations away on either side. So it's plus or minus 3. And just to clarify, each one of those lines I drew, that's how far a standard deviation is. The rule for finding outliers from a box plot is 1.5 times the IQR. So the IQR is how wide the box is, the interquartile range. So you take that number and you subtract it from Q1. This is right from your formula sheet, it's IQR, and you add it to Q3. So if it's further away than 1.5 times the interquartile range. The IQR is Q3 minus Q1. That's how you get that number. For this list of numbers, there's 1, 2, 3, 4, 5, 6, 7, 8 items in the list. We want the 75th percentile. So we take all 8 numbers, multiply them by 75, because that's the percentile we're trying to find, and divide by 100. That comes out to 6. So the 75th percentile is the 6th number in the list, which is 95. So a score of 95 is the 75th percentile. We are going to label this bell curve and use it to answer the rest of the questions. The mean score was 80. You always put your mean in the middle. The standard deviation was 5. So that means each one of these lines is 5 units away. So 80 plus 5 is 85, plus 5 is 90, plus 5 is 95. And now the other direction, we subtract 5. So 80 minus 5 is 75, minus 5 is 70, minus 5 is 65. So we have the curve, and we need to label what percent is inside each of those. So the percentages are 34 and 34 are within 1 standard deviation of the mean. Then 13.5 and 13.5. Then 2 and 0.5 in that tiny little part right there. So now we can answer the questions below. What percent scored between 75 and 90? So between 75 and 90, we just add up these numbers, 34, 34, and 13.5. So 34, 34, 13.5 gives us 81.5%. Next, what percent scored between 90 and 100? Well, that'd be, 100 would be way up here, right? So that would be 2 plus 0.5, which is 2.5. Where did I get those numbers? Here and here. What percent scored less than 70? So we look and find where 70 is, and it's right here. So from here back, it's 2 and 0.5, so that's also 2.5%. And next, what else do we need to find? Next, if there were 32 kids in the class, how many? So we're not trying to figure out the percent, but actually how many kids scored above an 85. So first we'll figure out what percent that is. So 85 and higher will mean we need to add 13.5, 2, and 0.5. So 13.5 plus 2 plus 0.5, that gives 16%. So 16% of the 32 kids in the class scored above an 85. So to figure that out, we need to figure out 0.16, because that's the decimal for 16%. Of means we multiply, and 32. So 0.16 times 32 is 5.12, but we can't count that 0.12 as a student, so our answer is 5 students. Similar process for letter E. How many scored below a 65? Well, only 0.5% of them scored below that. So what's 0.5% of 32? Well, we have to change that 0.5% to a decimal. So we take that decimal and move it 2 places, which is 0.005 times 32, which is 0.16. Well, that's not enough to be a whole student, so basically nobody scored lower than a 65, which is good. Name an outlier. All right, we just have to be more than 3 standard deviations away from the mean. So from an 80, here's 1, 2, 3. Anything higher than a 95, so I would accept anything greater than 95, so like 96 or 97 or 98 or anything like that. 96, 97, 98, etc. And then a lower outlier would be anything 1, 2, 3 lower than a 65. So anything less than 65. And that's it. I wish you the best of luck on your test. I know you will do great.